This video is about a specific feature available in Omnikey 5022 reader writer, that is the transparent session. So this video will be useful for software developers or students who are learning to program NFC tags. See, the transparent session, this is very unique to Omnikey 5022 reader writer. It is not available in the next version of the reader writer, that is 5023 and 5027. So if you're looking for a transparent session commands, so you have to watch out before you buy. So if you buy 5027, you'll not be getting this transparent session commands. So what is the purpose of this transparent session? Why do we need this? So this is required only if you want to send the commands directly to the cards. Assume that you want to send a card specific commands which is not available through the API that comes with this reader writer. Say ISO 15693 commands, or a commands available in ntag 213 or desfire command, etc. So using this transparent session, you can send any command directly to the card. That's one advantages. And you might come across so many applications where you have to do this type of command transfer. Now what I'm going to do in this video is I'm going to make you understand right from the developer's guide that comes with this reader writer. And the developer guide also has got a nice example on how to use this transparent command. So probably this background, so you'll be in a position to send any command. Say you take any latest ISO 15693 tag, and you can if you come across any custom commands for a tag, you can send that directly to the tag. And without this transparent session command, you will not be in a position to send any tag specific commands. So get this copy of developer's guide from the Omnikey website, and the transparent session is available in chapter number 8. So this is the command you're going to use, you're going to learn. Now first I'm going to skim through all the things I'm going to discuss in detail. So you have to read this section 8.1, and everything from in this chapter is related to the transparent session. So there is a command called get version and enter transparent session. So before you send any custom commands to the tag, you have to first enter the transparent session. Then you can exit from transparent session using this command, the 8.131, and there is a command you can set the protocol. If you look at here, then these are very low level commands. You can send what type of tag you'll be using. Assume that you want to send custom commands to ISO 15693 tag, then you can use the set protocol command. You can set the speed of transmission, and you can turn off on the RF field. And this is the most important thing. This is the command you're going to use to send the tag specific commands, and you have to understand everything over here. I'll be spending most of the time in understanding this command, and also you should know the output of this command, whether it's success or if it's error, what type of error is that. Now this is a nice explanation here. They're using the transparent session, it explains how to use this thing. And when I mentioned about we are going to discuss the examples, these are the examples I'm going to discuss. So look at here, there is an example that's for Mifare UltraLED EV1. So UltraLED EV1 is a command. It's a very tag specific command called get version. So there is no way you can execute this command for UltraLED EV1, but using transparent session you can. If you look at the sequence here, first you enter the transparent session, send this command, you get a response, then send the use the trans receive command. So you have to look into the documentation of Mifare UltraLED EV1 to know what is the command. So you have to send that command. Then once you get a response, you can exit this thing. Now this is a sequence you're going to follow. Enter, send the command, exit the command. I'm going to show you this command. This is a very low level Mifare tag activation command. I'll be using the Mifare Plus because I don't have Mifare Classic. So it looks like in Mifare Classic these are pretty outdated now. So I'm going to show you how to do this thing using Mifare Plus. And you can see here, enter the session and turn the field off, then set the protocol. So here the field is off. Set the protocol. So this says we are going to use ISO 1443A tag. Set the speed. This is the standard speed of Mifare tags. Send the REQA. This is a very typical activation process. REQA. I made many videos long ago explaining how this activation works. So send the request, do the first active anti-collision. Okay, then this is the second step anti-collision, and after that halt it. Then you're going to get some other command here. Okay. See, this is the container for sending all the transparent session commands. You'll always have the CLA, which is this FF. We'll always have this INS, which is 68. We'll always have the first parameter P1, which is 03. And in P2 is where you're going to send what type of command you want to do. Do you want to set a protocol? You use the P2 as 00. If you want to set the speed, use 01 here. If you want to set the field, use 02 here. If you want to do the trans receive command, use 03 here. And if you want to enter transparent session, use 06 and exit something. Okay, so this is what you want to do. Now LC, this is a command length. So the command length depends on any data you pass in the data field. So assume that for set protocol, okay, you will have like what protocol you want, say 03 is what you're going to send as a data field. So because you're sending 1 byte, the length is 1. So the LC is the number of bytes you send here. So this is the expected response bytes, expected length. So you don't have to send this thing. So if you send, I'm going to see a few examples. Okay, either you don't send this byte at all, it means you are ready to expect any length from the tag, or it's quite possible that you can also send 00. So we are going to see that whether it's 00 or nothing. So 00 means you're not very specific about the number of bytes you get from the reader. You can get any number of bytes. So that's it. This is just a container. I could say this is a wrapper, and depending on what you want to do, you'll be using the value into the P2. Take example of this the set protocol command. So here, this is again this is a wrapper. This has to be the SLA. The SLA has to be FF. INS is 68 and P1 is 0E. and this is where everything changes now. P2 is the P2 tells you're using set protocol, and look at this, the data field. Okay, if you want to set the protocol to use say Felica tag, you will be end up sending 06 here. Because you're sending 1 byte, LC will be 1 byte. Now if you see a dash here, it means you don't have to send any value for LE. So if you want to know number of bytes you send, this command has got, you got 1 CLA, this is the 2 INS, is a 3, 4, 5 and 1 byte 6. Okay, so the set protocol will have 6 bytes. Now look at the command of this set speed. So you got a CLA, FF, INS 68, P1 03. These are all the fixed values. Now P2 you have 01. So 01 indicates it's a set speed command. Now after that you got LC, but to understand LC you should know what is happening in the data field. So you have to pass the transmission speed, the reception speed, and you have to pass a RFU for future reference 00. So you are passing 3 bytes here, TX, RX and RFU. So for that reason you will have the value of LC is equal to 03. So in order to understand this transmission commands in OK5022 reader writer, so you have to understand a few concepts about how the tags are activated. So go to internet and get a copy of this document. This is the Mifare ultralight datasheet. We'll be using the REQA. So this is the request command. So this command you have to send a 26 to the tag. The most important thing you have to understand here is which without this you can never use this the transfer instruction. So look at here, when you send this 26, you have to send 7 bit to the tag. So if nothing is specified, you know that a byte has got 8 bits, all the 8 bits are sent to the tag, but doesn't work like that way. So the tag is expecting just a 7 bit of data, and that is 26. That's one of the crucial point here. So the transmission session will allow you to decide how many bits you're going to send to the tag. And the next important thing is about the integrity mechanism. In most of the tags, you'll come across either it's going to be parity or it can be CRC. So these are two things. So whenever you send, whenever this REQ is sent, you have to send, in the sense, the reader has to send the parity. So it's not enough that you just send 7 bit to the tag, you should also send the parity. So to keep this in mind. Now on the response side, the tag will reply with the 4, 4 and 0, 0. Again, when this response is received, the tag will not send neither the parity nor the CRC. It will just send the raw data. So these are the full bytes. It sends 4, 4 followed by 0, 0. So that's one thing. Okay, very similar is for UPA as well. Again, 52 7 bit, and the parity is what the tag expects. And again, you're going to use all this parity or no parity or CRC or no CRC. You're going to use only in the transitive command, because all of the commands, they're all standard. These are predefined command understood by the OK5022 reader data. Now if you start looking at this transitive command in detail, We already seen FF680E 03, all these are fixed values. And LC also, we know what is LC now. So LC will have the length of this data field, which it says there is some fixed 10 bytes, okay, plus the generic command. Now these header 10 bytes is what you see here. You got 1 byte that tells about all these flags we just discussed, what to send during the transmission and what to expect in the response, and the valid bits, how many bits you're going to send in the last byte. That is, are you going to send, do you want the reader to send 8 bits or 7 bits or 4 bits? Okay, now what kind of timeout? So usually don't have to worry about that. Just set the timeout to 000, all zeros. So you can decide how long you want the reader to wait for the response to come. RFUs, this is some good news. You don't have to worry here, just put all 000. So this is the header. Header 10 bytes means 1 byte here, 2 here, and this is 8 here. Okay, now what the document says here is, see, RX, TX and RX flags by defines the action taken by the reader when the data is sent or received. So there's something is clearly mentioned here. The valid bits define the bit length of the data, whether to send is it a multiple of 8 bits or it's just less than 8 bits. The timeout specifies the amount of time reader should wait. Okay, now we know that. Look at this. This is the most crucial thing here. So out of this, all this 10 header bytes, the only thing you'll be really struggling to get everything working instead of playing with this and this. Only these two things, nothing over there. Okay, see this TX and RX flag. To go back to this command here, so we want the reader to send only 7 bit of data, and we also want it to send the parity. It's a parity is was what used for error detection. So to do that, the valid bits, we want that to be 7. If you go down, this is how you encode the valid bits. So bit length is a whole number of bytes. So set to 000, all zeros. It means you always transfer in terms of 8 bits. Now number of bits to be transmitted in the last byte, we want this to be 7. So you're going to put 111 here. Okay, so all zeros 0111. So we want this to be 07 is what we want the value of the this byte here. Now transmission, okay, no CRC to send this particular command. Are you clear? No CRC. So tag is not expecting you to send a CRC. It just needs a parity. Okay, just in the parity. That's it. And also the response will also have just a parity. Okay, so we have to send 1 in the bit position 3 and a 1 in bit position 1. So if you convert this into decimals, you will have 0000 1010. It is 10. It is 0A. So very first command you have to send 0A for TX and 07 here, followed by the generic command. What is the command? Now this is where you're going to replace the commands from the tag. It is, you want that to be 26. Okay, now let's see what the example says here. Okay, look at that here. FF6803, sorry, 0, they're sending 03, sorry, 03, sorry, 0E. It's all the standard byte. 03. So what is that? 4th byte corresponds to? It's 03. Again, this is standard. And if you see the length, it will be 10 plus 1 byte, isn't it? 10 plus 1 byte, because this command takes only 1 byte. There's no additional parameters. It has to be 11. So here you got 0B. You can see this is 11, isn't it? 0B. Then look at that 0A. We just now decoded. It has to be 0A. Okay, so 0A is telling that to send the parity, and also when the response comes to check the parity. So that is 0A, and we also know it has to send the 7 bits of data, so that is 07, and the next 4 bytes. So this is this just, I don't know, this is just a timeout. Okay, you can just use this timeout. So this could mean probably 10 milliseconds or something. Okay, the 4-bit timeout. So I've used this 4 bytes as 0, still work for me. Or you can put, depending on the, if you look into any tag specific commands, probably you will know, look at that. So it says here. So I'm not very good in this timing, but if you add up all, it'll say, so totally it will take 360 microsecond. So convert this 360 microsecond to a 4-byte value and stick those 4 bytes here. That's it. And remaining 4 bytes, the documentation says it's 0. Okay, so RFU. It's good to have so many RFUs in a command. Zeros. Then the command. So the command is a 26 command. Okay, not sure what this FE, what that FE stands for. So FE, so generic command is fine, and this is supposed to be 0 actually. So in the transitive, you should always send a 000. Okay, now it's quite possible this could be a typing error, but I've sent 00. It worked for me. So now we know what's RQA. Okay, the most important thing here is how do you decide this transmission flags, and how do you decide, okay, the number of bits. Okay, so most often this will be 00. Okay, only when you have to send like RQA type of command where you need the 7 bits. Okay, now this is just a theory, and I'm going to show you how to how all this thing works. In fact, now I'm able to find one Mifare Classic tag here. I'm going to use that. So I'm using this software written to work with the Omnikey reader writers. This is software used in the training center, and the version is 2.10. Go to menu and choose the APDU console. So refresh. This is the reader I got. I've connected 5022. Probably I can show that my reader with the video. So you can see here I got my Omnikey HID 5022. So I'm going to place this Mifare classic tag, and if you go to the APDU and say click on this, it detects this reader. So first thing you do is so what you do is just to remove this 35000 if you're using this software. So connect the reader and connect to the card. So now we are ready to send the commands to the tag. So the first command is I'm going to start everything from the beginning. So we are going to start the transparent session. Just type here. Now this is the command for transparent session. Okay, so this is exactly the what document says. FF680E0601 and followed by 00 is the length. So if you look at the documentation here, if you look at this example, look at that. This is the transparent session. So 0600. I'm not sure why you got 00. Just go to enter the session. Yeah, look at the enter the session here. Actually something is wrong there. So this is the command we're supposed to send. FF680E0601 and 00. Okay, but the command given the example, so I'm not sure, my developers must have tried and they might have seen this did not work for them. So you just stick with the what's working for us. Okay, we'll stick with this command. Okay, so if you're watching this video now, just change the speed to 1.5x. okay, so I speak very slowly. Okay, so we are going to send that command now. So send this command. You don't have to worry about playing with the flags and number of valid bits. Now these are just a standard command that belongs to the reader. Now when you send, so this is a response you get. You got 90, so that's fine. So the next is okay, so here, okay, turn the field off. So again, these are the standard commands, so you have to just go and see the documentation here. Let me go through this once, so it will take some time, but you'll understand better. So set the field is off. I want that to be off initially. So it's an FF680E0201 and the state of this is 00. Okay, so let's check what the document is doing here. So they're also sending a 00. Okay, now I got this command typed in my notepad, so in my other screen, so I'm just copy pasting that. Control C. So take this out and put this and say send. Now we got 90 here, so that's the response. Now the RF field is off. Next is set the protocol. Set the protocol to 1443A, and this is the command again, because the first time we are using. Let me go through that at least once. So set the protocol. Okay, here. So we want to set this to type A. So here the protocol type is what you can specify. It's a type A tag, so that will be 02. Okay, so set that. Take this thing out, Control V. So you got this response 90. So we have set the protocol, and the next thing will be so we have to set the speed as well. Okay, so set the speed again. First time we're using that, we'll go and see this command, set speed. Yeah, set the speed is over there. So we're setting both RX and TX at the same speed, 106 kilobits. If you're working with like a Desfire or Desfire, and you can go up to 848 kilobits per second. So here everything is standard up to here, and you have to send 3 bytes with the 00 for this, 00 here, and 00 here, all 3 zeros. Okay, so the command for that is this send. So you got that. So far it's fine. So the next after that is REQA. Okay, REQA, and here everything was okay, but this FA, this is supposed to be 00. So I've got in my list of commands in notepad which has got 00. Now I got some nice comment as well. Okay, I got some comment here, probably I can show that. This is the comment line. So this is the comment I've got in my document. It says We have seen this command already, isn't it? We know 26 and 00 we want, but these 4 bytes, these are equivalent to 1 second. So if you convert 1 second into hexadecimal, you get this number. Okay, so that's what it is here, and I'm sure this is in the reverse order. So the actual value is 0. This is the MSB, but when you start sending the value, you have to send the low significant byte first here. Okay, so this is the REQA, and we already know that it is set for check for parity and send parity, and send the 7 bits. Okay, now go send. Now we got the result 000009. You have to understand this as well, so at least once. Okay, we have to understand that what the response is. Now go to this command, go to the transistor command. Yeah, not here. Yeah, so if you see the transistor command, there's a lot of information there as well. Now the response will have, you'll have first 2 bytes, then followed by the RF status, control status, followed by some responses here. Okay, now the status byte, the STS. So here, sorry, you got 2 bytes here. So you got STS byte and the RNB bytes. Okay, so STS byte, if it is 00, it means a transistor command succeeded. If you get any other number, so here either one of 1 to 7, it means an error. So if you look at what the first byte we got in response, we got 00. Okay, so that is the success, so that's fine. The R and B, so RB probably it indicates the receiver byte. Go to next page. Yeah, R cross B is number of valid bits in the last byte. Okay, now if you look at the documentation here, the response is 2 bytes. This is the first byte, this is the second byte, and since the response is full byte, it will have all the 8 bits. So if this is the first byte that is sent and this is the last byte that is sent, the last byte we are receiving all the 8 bits. So that's what this document says. So RB, so if you scroll down here, now actually, yeah, I think this RB number of bits here, I think this goes back to the same yeah, it's the same thing as here. Okay, all 0 means the bit length is in whole number of bytes. Okay, so we got 00 there. Okay, we got 00, that's it. So followed by, okay, you have to get the response. Now I got 0400. It is because mine is a Mifare classic tag, which has got only 4 bits of UID, whereas this document what I got here, so this is for ultralight, which has got 7 bytes of data. So 4400 means it's a 7 bytes, but I got 0400, so that's a 4 byte. Okay, so if you get documentation for Mifare classic, you'll probably come to know, you'll see this 04. Let me try if I got any document, probably later I can show that. Okay, so we are okay with that. So afterwards we have this 9000, and every response must end with the 9000. So if you look at the documentation here, so it says the first 2 bytes followed by the actual card response, followed by the 2 usually we call SW and SW2 byte, okay, which is a 9000. Okay, so we are able to get a response for this REQA. So I just found this document, and you can see here for Mifare classic, the REQA will return you 0004. Okay, so after that, the next command you have to send is the first anti-collision. So we have to send this command, but we have to see what are the command bytes for the first anti-collision, so which is over here. So I have to send the 93 and the parameter is any number from 20 to 67. We want to send 20. So look at it, this is an example. The first anti-collision is 9320 and the part of the UID, okay, not now, okay, it's the next step. You're going to send that. Now you also have to send the parity bit, okay. So this, the parity is what decides, you know, the error bit here. So we know it's going to be 0A. The response will be the part of UID. If you see the response, you get 88. First is always 88, followed by the 3 bytes of the UID, followed by the BCCI. Okay, so the response will be 5 bytes. So main thing for us is understand how to send this command. Okay, so luckily, you know, there is no 7-bit thing here. Everything goes as 8-bit. Okay, so I have got this command. Okay, we don't need this thing now. We've done that. So the command is, okay, this one, Control C. Okay, so here, you know, 0, 6, this is the 10 plus, you know, 10 plus the number of bytes, isn't it? So 0, 6 is 13. Look at that, I still have 0A, it's a parity bit, and 0, 0, you know, the response will be full byte, 0, 0, and these are the timings. 1 second I've got. Now the command is 9320 followed by 00. Okay, actually this is 10 plus see the command is 2 bytes, isn't it? 0, 3 and 3, 2. So 2 bytes plus the 10 bytes of header. So here 0C means 12, so that's fine. It ends with 00. Okay, now if I send this command, so look at that, we got 00. Again, we know it's a success. Next 00, you know, it's a 8 bits of in the last byte, and these are the 5 bytes we get, and we need this value to send the next command. Okay, so if you see the documentation, okay, if you see here, so we're done with the first anti-collision, and if you go to next step, the next is the select command. Yeah, actually, you know, both the commands are here. After the first anti-collision, you're going to select the tag. To select it, you're going to send 93 followed by 70, and you have to send the first 3 bytes of the UID and followed by the parity, and you know, in the everything is going to the, you have to send the BCC, and the CRC is there as well. So you have to make sure, tell the reader to send the parity, to send the CRC, to check the CRC, check the parity. Okay, now if you look at this example, okay, so this is what you are going to send: 9370. Everything we received 88, followed by this 3, everything, you know, all the 5 bytes we received in the anti-collision. You have to send it, and you also have to send the CRC as well. So you have to tell the reader to send CRC parity, and the response will have a 04. The response will have, actually this is a 4-bit of value. Okay, and the response will also have the CRC. Okay, now if you go to documentation here, this is the most important. If you understand this bit, you know, there's nothing more to play with that. That's it. So if you go here, okay, now we want the reader to send the CRC. So this is 1. We want reader to send parity. We want this to be 1. We want the reader to check the CRC from the tag. This is to be 1. We want the reader to check the parity. This has to be 1. Looks like, you know, looks like all these 4 bits need setting to 1, and I'm not sure what exactly this one. Okay, set that to 0. See what the example does here. See, so it has to be FF. Now the first anti-collision, this is continued here, so there is no example for, yeah, I think there's something over here for this one. Okay, so anti-collision, you have to set this as look at that. So this is the first anti-collision. This is the example of the select. Just scroll it. Okay, yeah, look at that. So we have to send 0F. Okay, so you know what FF is now. CRC parity while sending, CRC parity when you receive it. Okay. Okay, so this is the command. I got all XXX. You know, I have to replace this with the response I got here. This one up to here I have to send. So Control C and go here and Control V, and I have to delete this space. If you're using software, make sure you follow this same method. There shouldn't be any space in between. Okay. Now I don't need this anymore. Sorry. Okay. Now if I send this, let's see what the response we get. So the response is 0000. I got 08 and followed by 90. Okay. So if you go to this documentation, okay, if you see here, so you got it 04. Actually get it 04 here, but again this could be for a different example. Okay. Now I would probably now I think that's all. You know, we know how to send this thing now. Probably this is because say 00 is a success and 08 is also saying that you got 8 bits and the response was 8 bits as well. So we have to see some other document to see what this 08 is all about. So in fact, if you go back to this Mifare classic documentation, it says the response should be 08. Okay, so I think we made it through. So now I think we understood, okay, how this the transparent command works. So a couple of things you have to keep in mind. It's about how to use the parity bits, and that's all. You should know how to use the parity bit and CRC. And the main thing is, how do you decide? You can't decide on your own. You have to see what the tag expects. So if you go through a documentation like that, you'll come to know. So if you come across, say, look at the response here. If the response says there is a see this is a command. If the command says a CRC is going, you have to make sure that CRC bit is set to 1. Okay, this is set to 1. Okay, and if you come across, if the command says, okay, there is a parity here, and you have to make sure, okay, you set this parity. And again, if the parity, I think by default parity is always there. I don't think there's any command where parity is not set. And the CRC again depends on the command and the response. And look at here, in this response we saw the response getting this CRC as well, and you have to tell the reader that there is a CRC coming from the response. Okay, process it and don't send this to the next layer. Okay, take any command here. Just take a random command and nothing to do with the activation. Say read command. Look at here, it's a read command. Okay, so this is the command to read 30 address CRC. That's it. You have to tick both parity and CRC. Look at the response here. Okay, you got a response that says that's CRC. So you have to tick that. So when you send this command directly to read a block, you'll having a flag that's set to 0F. All 4 bits are FF. Okay. So I hope you understood this concept here. So I'm going to stop here, but in the next video I'm going to show you is literally it's just a repetition of all the things I did here, but I'm going to use a Mifare Plus tag, and I'm going to show you how this anti-collision 1, anti-collision 2 works, and also show how to convert the Mifare Plus to Mifare Classic. Okay, thank you.